afternoon, students. Very good afternoon to all. Today we will discuss about some problems in transient. Okay. In the previous discussions, we have seen that part is transient. Okay. Part is there in the circuit. Suppose after switching, how the circuit is behaving. Okay. That we need to find in transient response. Okay. So why we are analyzing this transient response? Because in order to improvise the transient or switching characteristics, we have to analyze this transient response of any network. Okay. So also we have discussed this. So today we will solve another problem. Okay. So in your online classes we have discussed that why this transient response need to be analyzed. Okay, why this transient response need to be analyzed. Transient response is nothing but transient response transient response is nothing but is your switching response, or I can say natural response of the system. Natural response of the system. Of the system. And sorry. So I can say that this transient response does not depend upon any input. Okay, this transient response does not depend upon input. Okay, what is provided to the system. Okay, and this response is called natural response of the system. Okay, another response is called steady state response. Steady state response. Okay, steady state response is called forced response of the system. Okay, forced response of the system, and this steady state response depends upon the input you are providing. Okay, suppose we will discuss these things in small details. We will discuss these things. Okay, what is the discussion? What is our forced response or transient response, and what is our steady state response? Let us see this. Okay, suppose you have a system of, suppose you have a bike. Bike means it is a very high standard bike, I can say. Okay, this is a high standard bike. As you suppose this is a pulsar bike. Okay, the pulsar bike system is this. Okay, and suppose I will draw here the system for your scooter. Okay, this is the system of your scooter. Okay, to both bike and scooter, I will provide okay acceleration input of 80 kilometers per hour. Okay, 80 kilometers per hour or 80 kmph I will provide to both bike and scooter. Okay, I will give input command to both bike and scooter to run at 80 kilometers per hour by giving acceleration by the accelerator. Okay, what will happen in how much time bike will attain that speed depends upon the system parameter or not. Yes. Okay, so after how many seconds it will attain 80 kilometers per hour, or it will attain 80 kilometers per hour, depends upon the system parameters or not. Yes. So suppose I will give him input command. Okay, I will give him acceleration to bike to run at 80 kilometers per hour. The same input command is given to the scooter to run at 80 kilometers per hour. Okay, so how much time it will taking by bike or scooter depends upon their pickup or not. That pickup of the vehicle depends upon the system parameter or not. Yes. So suddenly it is not reaching 80 kilometers per hour here, and this is not reaching 80 kilometers per hour. It will take some time. That time or that intermediate time is called transient. That intermediate time is called transient to peak that value to this speed. Okay, to peak that value or reach the value at 80 kilometers per hour, it will take some time and it will take some time. That time depends upon the pickup value of this and this. Because scooter pickup value is less than this pickup value. Okay, it will take less time to reach that destination or reach that final value. Okay, so what you observe here, it will take less time to reach that steady state value. Okay, so here transient time is less. Here transient time is less. So this transient behavior of the circuit depends upon the circuit parameters or system parameter or not. Is here the pickup value is more, the transient time is less. It is taking less time to reach 80 kilometers per hour or not. Is here the pickup value is less, the system parameters are less advanced. Okay, so it will take more time to reach this 8 kilometers per hour or not. Yes. So what you observe here, the transient behavior of any circuit depends upon the system parameter. Okay, and the forced response or natural response depends upon only the input. Okay, both have to travel 80 kilometers per hour by anyhow, because you have given input command to both of these to travel at 80 kilometers per hour. It will travel at 80 kilometers per hour most most it will travel. Okay, so steady state will going to reach into system. Okay, but how many times after it will reaching steady state and it will reaching steady state, that time is called transient time. That time is called transient time. So transient time depends upon your system parameters, or transient time is the natural response of the system. Transient parameter is the natural response of the system. So mathematically I can, or method wise I can represent like this. So suppose this is the response of any system. Suppose this is I of t, this is t. Okay. Suppose I will draw the response of the system. Okay, suppose this is the response of the system. Finally, it will reaching this much time. Okay, up to this and this, is this is giving steady state? No, this is not steady state. This is oscillatory response. Then it will giving steady state response. This is giving steady state response after some time. Okay, what is this response? This response is called transient response. Okay, transient response. Okay, so this transient response depends upon the system parameters. This steady state response depends upon the input. This is one of the most basic thing you must know before entering into your transient. Okay, we have already discussed these things in your online classes, but I think that it is worth to discussion again these things, because it will be a conceptual foundation that should be laid in your heart actually. Okay, so let us see some problems. Okay, let us see some problems. Okay, so previous class we have discussed one problem. Okay, I hope you will all understood that. Okay, so today we will discuss another problem here. So what is the problem here? Let us see. What is the problem here? Let us see. So this is the problem. So suppose a voltage source is there. Voltage source is there. A resistance is there here. Yes, a resistance is there here. Another resistance is there here. Yes, and a inductor is present here. Yes, a inductor is present here. What is the value of this resistance? I ohm. This value is 5 ohm. This is 0.1 Henry. 0.1. Okay, so it is a sorry. It is a stepped voltage of 20 volt. Okay, so where switch is there? Switch is here. Switch is here. Suppose this is a switch. Switch is here. Okay, this is the switch. Okay, here this is the switch. Okay, this is the switch. It is observed place. It is observed. So what is the question he is asking? What is the question he is asking? The switch is closed at t equals to 0. So I am writing here the question. This is the question. Okay. The switch. Switch is closed at t equals to 0 second. Okay. Before that, the circuit is under steady state. Is telling. Okay. Before closing the switch, he is actually telling that before that means before closing the switch. Before that, the circuit is under steady state. Yes. Then what is asking? Then determine the expression of current from inductor. Okay. Determine the expression of current through okay, he is asking this thing. Okay, now we have to solve this. Okay. Yes. Let us solve this. Let us understand this question. What is happening here? Okay, then we will solve this. Very easy question. Okay, it is an easy question, but require conceptual clarity. So what is telling here? The switch is closed at t equals to 0. The switch is closed at t equals to 0. Suppose this switch is closed at t equals to 0. At t equals to 0. At t equals to 0, this switch is closed. Okay. Before that, before closing the switch, the circuit is under steady state. Okay, so see here, what is the solution here? Let us see. So I can say here one thing. Okay, I can say here one thing. At position number or okay. So before closing the switch, okay, before closing the switch, it is said that the circuit attains steady state. So before closing the switch, this circuit was open or not? Yes. So this circuit was open. See here. This is the resistance. This is another resistance. This is the inductance. Okay. And this is the voltage source. And the switch was open here. Circuited here. Okay, what is this value? This is 5 ohm, this is 5 ohm, this is 0.1 ampere, this is 20 volt. So before closing the switch, the switch is open or not? Yes. And he is telling that this circuit undergoes steady state. Okay. So at the steady state, how the inductor will behave? Short circuit. At the steady state, inductor will behave as a short circuit. Why? Because what is XL inductive reactance? 2 pi F into L. Okay, I can write it down. 2 pi L divided by 2. So at the steady state means this is steady state. At the steady state T equals to infinity. Yes, T equals to infinity. So what is XL? XL equals to 0. 1 by this much by infinity equals to 0. So XL equals to 0 means it is short circuited. Oh, okay, impedance is 0. Inductive reactance is 0. Impedance is 0. So that's why this is short circuit. So after steady state, before switching, it is attaining steady state means what? It is short circuited. So what is the current flowing here before switching? I can say that IL 0 minus will be what? divided by I plus I n equals to 2 ampere. Okay, so before closing the switch, this inductor attains steady state. So whatever the current flowing through this circuit before closing the switch, just before the closing of switching, what is the initial current flowing through the inductor? This is the initial current flowing through the inductor before this switch is closed at t equals to 0. This thing you have to first determine. Okay, this is very important. This is very important. Okay, 1 minute. Yes. Okay, so see here, we have determined the initial current. Next step we have to do. Okay. So what is the initial current we have found? Initial current equals to IL 0 minus is equals to 2 ampere. 2 ampere. Okay. So what we have to do next? Then switch is closed. Initial current is this. Switch is closed. Then what will happen after closing the switch? How the circuit will behave? Okay. This is a resistor or yes, here I am doing. The switch is closed at t equals to 0. Means what? Means here the switch is closed means it is closed. It is closed. Okay, so a short circuit path is there across this resistance between these 2 points. What is there between these 2.1 resistance is there, one short circuit path is there. So current will prefer to flow here, not here. Okay, as current is not flowing here, I can make this resistance redundant. Okay, so this resistance is removed from the network in the analysis after switching. Okay, so this resistance is removed. Okay, so what will happen? Suppose the IT amount of current is flowing when this switch is closed. Okay, so here IT is flowing in this direction. This is positive, this is negative, this is positive, this is negative. Yes, simple. This is positive, this is negative. Okay, so write down KVL, put KVL, put KVL. What you are getting? To T U of T. Okay, is equals to 5 into I of t plus 0.1 L dit by dt. Dit divided by dt. Yes, yes. So after putting KVL, what you have to do? You have to put Laplace transformation. Laplace transformation. Okay, you have to put Laplace transformation. What is the Laplace transformation of this? 2t divided by Laplace transformation ut is equal to 1 by s. So all of you please go through the Laplace transformation. Without Laplace transformation, you cannot do transient properly. Okay, I repeatedly tell you, you are in the third semester now. Okay, so you are in mathematics, you have Laplace transformation. So all of you please go through the Laplace transformation. Okay, 1 minute. Yes. Okay, so by putting Laplace transformation, what we have got here, the Laplace transformation of ut is equal to 1 by s. So 20 by s is equals to 5 into is loss. What is the Laplace transformation of derivative? S into is minus il 0 minus. This is the initial current flowing through the circuit before switching. Before switching, this inductor attains steady state. What is the current flowing through this inductor before switching? 2 ampere. 2 ampere. Yes, 2 ampere. Okay. So put here 2. Put here 2. So what is the equation you will get? 5 into is plus 0.1 s into is minus 0.2. Put 2 here. 2 into 0.1 is equals to 0.2. Okay. So after simplifying this, you will get the expression for is like this. Okay, so I have simplified this. Okay, put is here and write the expression. You will get the expression like this. Simplify this, you will get the expression of is like this. Do this at your home. So is का expression ऐसे लिखेगा 20 plus okay 0.2 yes I love this. Okay, divided by 0.1 s whole into s plus 50. All of you please check this after doing this. Pause this video, derive by yourself in your home and do this. It is not a theater you are watching movie. Okay, it is not a theater that you are watching movie. It is all about how you practice it, how you practice yourself, how you learn the things, how you make struggle your mind. Okay, if you not learn the thing or not struggling your mind, you are not learning anything. Okay, nothing is achieved without struggling. Okay, so in order to learn something, your mind need to be struggled. Okay, so you have to do this by yourself in your copy. By pausing the video, you do this in your copy first. Okay, then cross check it. Okay, then cross check it. Okay, 1 minute. So see here, the 0.1 here, I can say here 1 by 10, 10 will multiply here 200 plus 2s divided by s whole into s plus 50. Okay, so I can divide it like a by s plus b divided by s plus 50. By which method? By partial fraction. Okay, so derive a here. What is a? What is the denominator of a? S multiply s into is this expression 200 plus 2s divided by s whole into s plus 50. What you put in place of s equals to 0. S will cancel. Put s equals to 0. S equals to 0. 200 divided by 40 is equal to 5. 50 is equal to 4. Okay. Then what is b here? B. What is the denominator of b here? S plus 50. Multiply s plus 50 with this. Okay. So s plus 50 into 200 plus 2s divided by s whole into s plus 50. So in place of s, what you have to put? Minus 50 because they equate s plus 50 to 0. Okay, so s is equals to minus 50. So put s is equals to minus 50. What you have to, you have got s plus 50, s plus 50 will be cancelled out. This is minus 50, this is minus 50, minus 100, 100, minus 50, minus 2, minus 2. Yes, this will be minus 2. Okay, so a equals to 4, a equals to 4, b is equals to minus 2. Okay, here we have to write down what is IT. What is IT here? What is IT? Laplace inverse of IS. Okay, so what is IS? This Laplace inverse of 4 by s plus Laplace inverse of minus 2 divided by s plus 50. Okay, so what is Laplace inverse of 4 by s? 4 into ut. What is Laplace inverse of minus 2 divided by this? This is minus 2 e to the power minus 50t. Okay, so what is the last expression you are getting? 4 minus 2 e to the power minus 50t will be the expression for your correct. Will be the expression for your correct at instant 2. Okay, at instant 2 this will be the answer. Okay, one second. Yes. So, what is the expression for current you are getting here? This is the expression for your current you are getting. So, this is the answer. Is this difficult? No, this is very simple. Okay, you have to follow the procedure. Without following procedure, you are not getting anything in your life. Okay, so this is the expression for your current that you are getting here after closing the switch at t equals to 0. Before closing the switch, this circuit undergoes steady state. You have to derive what is the current first in the steady state. Then you have to close the switch. After closing the switch, put KVL. Okay, you have to put Laplace transformation to convert the time domain equation into frequency domain equation or S domain equation. After converting the time domain equation into the S domain equation, you have to put partial fraction. Okay, partial fraction. Then after putting partial fraction, you have again find the what? IT. Okay, what is IT? IT is the response of the system. What response? IT is the step response of the system, because what input you are providing here, step input you are providing here. Write down one assignment problem. Write down one assignment problem. Same problem you have to do. Same problem you have to do. Same problem you have to do. you have to write input. Here input is, suppose here input, sorry, this is not right. Suppose here input you are providing, okay, okay, 20 RP you are providing. Okay, question is same. Question is same. Here switch is there. Here switch is there. Question resistance is there. Okay, this is 5 ohm. Okay, question is same. This is ramp input. Okay, all question is same. All question is same. But write down here the input is active. The input is active here. This is the ramp input we are providing. Before that, you have used step input. Now it is ramp input. You have to do this as your home assignment. Okay, 1 second. Yes, you have to do it as your home assignment. Okay, so what is the Laplace transformation of ramp input? What is ramp input first? What is the expression for ramp input? RT equals to T. I can draw RT like this. Okay, suppose this is T, this is ramp input. The ramp input will pass through the origin, straight line passing through the origin. Okay, so what is the Laplace transform of ramp input? Laplace transform of ramp input will be 1 by s. Remember this. Okay, so what is step input? Step input is equals to u of t is equals to 1. Okay, it is called unit step response. Okay, suppose u of t is equal to k, this is called step response. Okay, step input. Okay, so suppose this value is k, this is k value. Suppose this is u of t, this is t. I can say that u of t is equals to k for t greater than equal to 0 and 0 for t less than equals to less than 0. Okay, so what is the Laplace transformation of ut? Laplace transformation of ut is equals to us is equals to k divided by s. K divided by s. Suppose this k is 1, suppose this k is 1, then I can say that this is a unit step input. Unit step input. Okay, okay, so this is the thing, this is the thing. So what is the Laplace transformation of this 20 RT? What is the Laplace transform of 20 RT? 20 RT, 20 RT, 20 divided by square, 20 divided by square. Okay, and all other things are same. Try this at home, try this at home, struggle your mind, learn something, excel in your life. Okay, so what is del t? Del t is equal to del t is equals to 1 at t equals to, this 1 indicates the area. Okay, this is the impulse function. Okay, impulse function, this 1 indicates the area of the rectangle. Okay, area of rectangle, dash rectangle area exists at t equal to 0. Okay, what is the Laplace transformation of del t? Laplace transformation of del t is equals to 1. 1. Okay, and another home assignment problem 1 is here, write down RT, and second question you will write down del t. What is the Laplace transformation of 20 del t? 20. Okay, so all of you please do this as your home assignment and send me in WhatsApp. Okay, send me in WhatsApp. Thank you. Thank you.